Hey everyone, ever wonder how AI could turn a simple description like a cozy two-bedroom apartment with an open kitchen into a full floor plan? Today, we're diving into a groundbreaking model called FloorPlan-DeepSeek that's redefining how we design spaces using language and math. Let's break it down. At the heart of this system is a clever way to represent rooms. Think of each room as a digital building block with specific details. The coordinates, Z tell us where the room's center is on the floor plan, while Y, high, define its width and height. Together, these form a room's vector, a mathematical snapshot that captures its size and position. All the rooms in a plan are then arranged in a sequence, like a storybook, where each room is generated one after another. Here's where it gets interesting. The model uses a large language model, like the ones that power chatbots, to predict the next room in the sequence. It's like writing a story, where each sentence depends on the ones before it. The model starts with a text prompt or partial floor plan and decodes the next room, building the entire layout step by step. This process isn't just random. It's guided by hidden rules that ensure rooms make sense together. But how does the AI avoid creating impossible layouts? Enter auxiliary constraints, the model's secret weapons. For example, functional adjacency. A bedroom and bathroom stay close, following real-world design logic. Editability. Rooms are designed with clear boundaries, making it easier for humans to tweak them later. Outline boundaries. No room can spill outside the building's walls, keeping things geometrically sound. These rules are baked into the model's training, teaching it to balance creativity with practicality. FPDS uses a vector-based representation, which is a data-rich format where each room is a labeled, structured element. Unlike pixel-based outputs, this allows for precise edits and integration into real-world design tools. The model starts with a partial layout and asks, what comes next? It leverages semantic clues from text descriptions to make informed guesses, refining the plan incrementally. This step-by-step approach mirrors how human architects design, iterating, adjusting, and refining. The results? Stunning. When tested against other models like Obj-GAN and Tell2Design, FloorPlan-DeepSeek consistently outperformed them. It nails room proportions, avoids chaotic layouts, and creates spaces that feel right, like a kitchen near the entrance or a bathroom next to a bedroom. Even in complex three-bedroom setups, it maintains coherence, proving that autoregressive methods can handle intricate spatial logic. Quantitatively, FPDS achieved an FID score of 16.465, lower is better, meaning its outputs are super close to real floor plans. PSNR and SSIM metrics also show high quality, proving it's not just creative, it's precise. These numbers highlight its ability to generate layouts that are both aesthetically pleasing and functionally sound. For architects, this means smarter tools that adapt to their workflow, not the other way around. Imagine describing a space in plain language, and the AI builds it incrementally, letting you tweak rooms, adjust layouts, and see changes in real time. It's like having a design assistant that thinks ahead, just like a human would. Of course, no system is perfect. The model still struggles with highly complex layouts or ambiguous prompts, but these are exciting challenges for future work. The key takeaway: by combining language models with architectural rules, we're moving closer to AI that doesn't just generate designs, but understands them. So the next time you imagine a space, remember, AI might soon help turn that vision into a blueprint. Thanks for watching. If you enjoyed this deep dive, hit subscribe and let me know in the comments what kind of AI-driven design you'd love to see next. Ever wonder how AI is reshaping the way we design buildings, enhance images, or even predict climate impacts? Let's dive into some cutting-edge research that's pushing the boundaries of machine learning in real-world applications. Imagine a world where AI doesn't just follow instructions, but reasons through complex problems. That's exactly what researchers are exploring in projects like MCTS-based in-context learning. Think of it like a chess player who doesn't just memorize moves, but adapts strategies based on the board's current state. By combining Monte Carlo tree search, MCTS, with AI models, scientists are creating systems that can tackle tasks like architectural design or image enhancement by thinking through possibilities, not just relying on examples. And it's not just about single tasks. Multimodal reasoning, where AI processes text, images, and data together, is revolutionizing fields. For instance, one study uses MCTS to improve low-light image enhancement, letting models understand scenes better and produce clearer photos. Another project, CARD, explores AI-driven residential design, where algorithms generate and edit floor plans based on natural language prompts. It's like having a digital architect that listens to your ideas and brings them to life. But the magic doesn't stop there. Researchers are also tackling sustainability. One team optimized building designs to withstand climate change, while others used machine learning to predict outdoor thermal comfort. These tools aren't just smart, they're helping us build greener, more efficient spaces. And in construction, AI is streamlining everything from anomaly detection in harsh environments to real-time energy feedback for architects, balancing aesthetics with eco-friendly choices. What's next? As these technologies evolve, they'll likely make complex tasks like 3D design, acoustic optimization, or even climate modeling faster and more accessible. The future isn't just about machines doing work. It's about AI collaborating with humans to solve problems we've never tackled before. So what do you think? Are you excited about AI's role in shaping our world? Let me know in the comments. Maybe we'll explore one of these breakthroughs in more detail next time.